We can continue on. We can do more of these probabilities. Let's say we want to know what's the probability that they're let's say air customers and Go customers. So what's the probability that they're an air customer and they're a Go customer? Okay. Well, in this case here, it's the probability that they're an air customer times the probability that they're a Go customer, knowing that they're an air customer. Okay. So what we end up with here, well, the probability that they're air, it's a simple probability. It's no compounding going on. It's just an air customer. You can see that there's 45 air customers, okay, out of 100. So we have 45 out of 100 is that probability here. The probability that they're a Go customer, knowing that they're an air customer. Well, we know they're an air customer, so we know that they're along this particular row here. They're air customers, so they're along here. There's some of them 45 people. So what's the chances that they're a Go customer? Well, there's 40 chances out of 45. So that gives us 40 out of 45, which you can see that these cancel, which gives us 40 chances out of 100 is the probability that they're an air and a Go customer. So you can actually see what's happening here. Let's say, for argument's sake, that we want to calculate conditional probabilities. Okay, so the probability tree allows us to fill in our marginal probabilities, and then also allows us to fill in the joint probabilities. If we want to calculate conditional probabilities, let me just maybe get rid of this page here for a moment. Okay, the conditional probability, you can actually see from this rule here, okay, okay, that we could actually calculate conditional probabilities really easy, because the probability of A and B is equal to the probability of A times the probability of B, knowing that A has occurred. So the conditional probability is this guy here. That's our conditional. Okay, so the conditional probability of B knowing A is the same as, so now we have the probability of B knowing A, it's the same as the joint event, the probability of A and B, divided by the probability of A. Okay, so this is how we calculate these conditional probabilities. Okay, so actually if we go back to our tree, okay, now I've already shown you how to calculate conditional probabilities by going to the contingency table, but let's say we want to use the probability tree to calculate our conditional probabilities. Well, let's say I'm interested in the probability, okay, of a Go customer knowing that they're pay as you go, knowing that they're air. Well, that's simply equal to the probability P, A and B, the probability that they're Go and they're air, divided by the probability that they're Go customers. Okay, you can see the okay, sorry, let me actually do this again. Let me actually flip this around. I'm getting this the wrong way around. You can see actually that the B represents this, the A represents this. Okay, so actually this should have been, let me just cross that off. Actually, what I'm going to do is I'm just going to go to a new page here. Okay, that's probably the best thing to do, rather than mucking this up a little bit more. Okay, so I want to know the conditional probability. So we know that the probability of B given A by the rule with our algebraic manipulation of this here is equal to the probability of A and B divided by the probability of A. Okay, so that if I want to calculate the probability that they're a Go customer knowing they're an air customer, well, what I need to calculate, okay, what I need to calculate is the probability that they're an air customer and they're on Go, because my B is Go, my A is air, okay, divided by the probability that, well, my A is air, that they're an air customer. Okay, if that makes sense. So you see the way these are representing that, and the A is representing this term here. So when we filter this through, the B should be Go, okay, the B should be Go, which it is, and the A's should be air, which they both are. So from our tree, if I can go back here, okay, from our tree, the probability of being an air customer and a Go customer, the joint event, okay, so the joint event is air and Go is 40 chances out of 100, okay, and we need to divide that by the probability that they're an air customer. Well, the air customer is the marginal probability is 45 chances out of 100, okay, so we invert and multiply. That's the same as 40 out of 100 times 100 over 45. The hundreds cancel, which gives us 40 chances out of 45, which is Oops, a daisy. Well, let me go back here, which is actually what we had earlier on. The probability that you're a Go customer, knowing you're an Air customer, okay, was actually 40 chances out of 45. Okay. The point being that there's many ways to actually capture these probabilities, but that when we have a probability tree, okay, here's our probability tree, okay, that the marginal probabilities are in the center, okay, typically are in within the tree, and the joint probabilities are out in the leaves of the tree. If you want to calculate the conditional probability, you take the joint probability and divide by the marginal probability. Okay, that's important. So in other words, if I want to find out the probability that I'm a bill pay customer, knowing I'm a Vodafone customer, well, I take the probability that I'm a Vodafone and bill pay, and I divide by Vodafone, the probability of being Vodafone. Okay. Guys, I'm sure that was very fast, but I hope it was in some way intuitive, and more importantly, I hope that was helpful. Once again, this particular video was looking at contingency tables and the generation of probability trees from those contingency tables, and I hope that was helpful. So once again, thank you for watching. Okay, bye bye.